Greetings, scholars! We're getting so close to the end. Here's your review. Part 17. This is a projectile motion question. Imagine that I am, shooting a gun or shooting an arrow. Does that sound better? From over here. Okay, and then let's say that 1,000 meters away is a deer. No, we won't say deer. We won't kill live things. Let's just say there's a target. How about that? So I've got a target 1,000 meters away, and I want to hit the bullseye. Here is the thing, okay, is that the target itself, the bullseye, is actually going to be about 0.5 meters down from here. Okay, in other words, when I shoot the arrow is actually right there, but the bullseye is right there. In other words, when that arrow takes the trajectory across, it's going to go and go into the bullseye of the target. So it takes, this kind of trajectory right there, like that. That's a hard word to say. Trajectory. Say it 3 times fast. Trajectory. So, the question is, what's the initial velocity going to be? Believe it or not, I can calculate the initial velocity that I need for my arrow if I know the range and I know the height. That's all I need to know. Okay, you're not going to like that we have to do this, but let's just do it together and then you will have it. So when you take your exam, you will remember how to do this problem. Let's break everything down here into x and y components and what we know. First of all, I know that my object is traveling horizontally 1,000 meters. Okay, great. What is the y displacement? How far down is it going to go? Well, it's right here. It's 0.5 meters. What is the one thing that both x and y share? X and y are completely independent of each other. There is one thing that they share. This is a free response. I want you to answer this question now. Time. Time is the one thing that they share. That is the only thing that they have in common, absolutely. Now, the acceleration on the y side is gravity. I'll just write a little g. Oh, I'll put 9.8. Okay, so what is the acceleration on the x side? I'm going to give you a multiple choice question. I want you to answer that now. Please tell me that you said acceleration is 0. There's no acceleration. It's moving constantly. If you remember our football problem, I'm hoping that you can kind of refer back to that idea. I could find that problem somewhere. What? Boom. Found it. The acceleration here, horizontally, was 0. The only thing that had acceleration here was the y velocity. So in the x direction, there's nothing. The only acceleration you have for a projected object is 9.8 meters per second squared down. Okay. My object is moving purely horizontally. You shoot it boom, and it goes out only horizontally at first. So your initial velocity in the y direction is 0. That's good. I need to find t. Once I find t, I come up here and I find v. What is velocity? I have it x equals tv, but we know that velocity is what? It's distance over time. I can just manipulate that, because that's actually what we're trying to find in the end, is the velocity here, the x velocity that I have to shoot it out with. Question is, how am I going to find time? The equation that I'm going to use here is y equals v naught t plus 1/2 a t squared. V initial is 0. So this entire term right here gets canceled out. So now what I have is y equals 1/2 at squared. Okay, so here is my y equals v naught t. I can cancel that out. 1/2 at squared. I'm going to put g. What is it that I'm looking for? I'm looking for t. Okay, I want to manipulate this equation to get t by itself. So it's pretty easy. I multiply everything times 2. Okay, that gets rid of the 1/2. I divide everything by g. That gets rid of that. And then I square root everything so that I get time equals the square root of 2y over g. All right, take this time to go ahead and calculate t. And I want you to put that, I want you to put that t in here. Go ahead and do that now. Okay, did you get 0.3 seconds? Because I did. Come back here. My velocity is going to equal some distance, which we said right there, it's 1,000. Divided by my 0.3 seconds right there. And the velocity that I need is 1,000 divided by 0.3. And that is, whoa, that's really fast. 3.3 meters per second. Boom. That is how you solve a projectile motion problem of this sort. Okay? Yay! You like that?